Okay, got the tagline? Let him go. Let him go. Stand by. Get ready to get him. You watch out for his foot there.
Oh, I think I can handle this buckle this time. Bill, what happened?
Yeah, I caught my foot in the grating. Twisted my ankle real bad. Can't walk on it.
Okay, let's get you over here.
Your coworker has just sustained an injury that prevents him from safely climbing down to the ground. It's a long way down, and it appears that the tower ladder is your only means of getting him off that platform. Or is it?
Hey, Al. Bill's messed his leg up. I don't think he can get down the ladder.
Hold on, I'll get help.
Get some help.
Poppy, there's an emergency on the cold box. Listen, you get up there on the tower.
All right, why don't you sit
You
down.
have another option, one that's proven reliable, easy to use. When you need to quickly remove an injured coworker from an elevated work site, you can rely on the Escape-Rite controlled descent device. It provides a safe and quick means of lowering personnel during an emergency. Simply remove the rescue cradle from the kit and toss over the tagline. Place the injured worker into the rescue cradle.
Okay, watch your ankle. I got it. Okay, I can drop the cable.
Toss over the return cable.
You clear? Okay. Now, let's make sure we get all these 3 points attached. Okay. Now we want to attach it to the triangle here.
Attach it to the escape belt's triangular D-ring,
Okay.
and with the help of those below, the injured party is lowered to the ground at a constant, controlled descent rate. The Escape-Rite controlled descent device is a lightweight, compact system consisting of a centrifugal braking system located in the unit's housing, a galvanized 1/8 of an inch steel aircraft cable covered with a weather-resistant neoprene and polyester braided jacket, and an adjustable escape belt at each end. A rescue cradle kit is also available for the unit. It can be used as a portable rescue system at remote locations, or can be permanently mounted at an elevated work site. The device must be suspended from an approved anchorage point with a minimum distortion strength of 1,200 pounds. Cable and termination points have a minimum strength of 1,800 pounds. The unit is designed for the individual use of persons up to 300 pounds. For rescue operations, the cable shall be twice the length of the highest anticipated work site to allow workers at ground level to assist with the descent. For permanent installations, the cable length must be measured from the unit's attachment point to grade level. For installations permanent or temporary, where it is intended only for escape purposes, the cable length should be the same distance as from the attachment point to the escape level. This is demonstrated here with the one person reaching ground level and pulling the extra few feet of cable through to bring the sling at the other end up to the man on the platform. When it is mounted for use in either rescue or escape operations, the cable again should be twice as long as the distance from the attachment point to the escape level. Then, for escape operations for a number of persons, it would be necessary for more cable to be pulled through to get the sling back up to succeeding persons. This system has been specifically designed for individual emergency descents from elevated work sites, as well as for the removal of injured personnel from higher elevations. No electrical power is ever needed to operate the unit. It works by gravity and automatically adjusts to your weight. The centrifugal braking system safely lowers you at a constant controlled rate, about 3.5 feet per second. A cross-sectional diagram of the unit's housing will help illustrate how the braking system works. As you are being lowered to the ground, the cable passes over this sheave, which drives these reversible gears. As the sheave rotates, brake shoes are automatically activated, centrifugally providing a controlled descent at a rate between 3 and 3.5 feet per second. When compared to other types of rescue lowering devices, you can see why the controlled descent device is an industry-preferred method to provide emergency descent. Ladders and cranes with work cages can be available to remove you from an elevated workstation, but each has its drawbacks in an emergency. Portable extension ladders may be limited by their height. If you need to escape from a platform 20 feet high and the ladder falls 6 inches short from reaching it, those 6 inches can seem like 60 when you need to quickly evacuate the site. Also, you need a steady support base for the ladder. This becomes increasingly important when the ladder is fully extended. Your weight can cause it to become top-heavy, and in an emergency, you need to make sure that you're on steady ground. Portable rope ladders are virtually useless in an emergency because of the great difficulty in using them. Because they have a tendency to swing back and forth, this swinging motion could cause you to lose your balance and fall. For these reasons, portable extension ladders and portable rope ladders are not recommended for emergency descent. A crane with a work cage can assist in the removal of personnel during an emergency, but it is often limited by the work area. If you're trapped on top of a platform between two cold boxes and there's no room to safely position it, you could be in for a rather lengthy stay. Additionally, a crane may not be stationed at the plant site. It could take hours before one is brought to the site, and it still may not do the job. Thus, the use of a crane is not reliable for emergency planning. So, when compared to alternative escape methods, you can see why a controlled descent device is an industry-preferred method to lower workers from elevated work sites. The Escape-Rite controlled descent device meets the NIOSH, National Institute for Occupational Safety and Health criteria for emergency egress, and OSHA Standard 1910.35 for emergency escape routes from higher elevations. It has been independently tested and listed by Underwriters Laboratory and is Cal-OSHA approved. Although numerous tests and governmental agencies have documented the safety and reliability of this system, under a variety of harsh environmental conditions, you must have confidence in using the unit. Many workers have questioned, how can such a compact unit work so effectively? That's where hands-on training plays such an important role, not only in training you how to properly use it, but also to bolster your confidence in using the system when you need it in an emergency. For classroom or on-site training, a portable, lightweight tripod, along with a portable stepladder, can be used with the system. This training is conducted from a comfortable, non-threatening level, about 10 to 12 feet above the ground. Where tripods are not available, other reliable suspension points at basically the same elevation can be used. For continuous fall protection, the escape belt is put on at ground level. It is placed over the head and under the arms. The adjustable buckle is pulled snugly to keep the belt firmly in place against the chest. To prevent you from falling, the slack from the return cable is pulled as you're climbing the ladder. When you're ready to descend, steady yourself with the return cable, step off the ladder, and let go, placing your arms to your sides. The device automatically controls your descent to ground level. You should also be trained in the operation of the rescue cradle should you need to lower an injured coworker from an elevated workstation. Remove the cradle from the kit and lay it out next to the victim. Place his arms through the holes of the cradle. And bring the narrow portion of the cradle up between his legs. Attach all 3 cradle rings to the cradle strap hook and then to the triangular D-ring of the escape belt. With the help of additional workers below who can help guide the cradle with the taglines, the injured worker can be safely lowered to the ground. Note, the rescue cradle would not be used for those individuals with suspected neck, back, or internal injuries. Immediately seek medical attention before attempting to remove the injured party. The system should be periodically inspected to ensure it's in proper working condition. The housing must be checked for any dents, cracks, or other types of damage. The installation snap hook should also be inspected for burrs, cracks, wear points, and other signs of distortion. Check the entire length of the cable by pulling it through the unit. You should experience resistance, which will increase the faster it is pulled. Look for any kinks, cuts, or any other visible signs of damage to the cable. The adjustable buckle located on the escape belt should also be free of any cracks or distortions. Make sure that the cable termination points are securely attached to the triangular D-ring of the escape belt.